In 6.1, we're learning about operations on functions. The operations we're learning are adding, subtracting, multiplying, and dividing. So pretty basic. So for number one, let's start by finding the sum of f of x and g of x. So that's called f plus g of x. And so I won't recopy the problems. We're just going to add these functions together. So 3x squared has nothing to add with. Then you're going to add negative x and 2x. So that makes positive x. And then 5 plus negative 3 makes plus 2. So there is our sum. Now let's find the difference. Okay, so to save room again, I won't recopy the problem. I just want to make sure I distribute a negative to both of these before I combine like terms. So this is going to be 3x squared minus x plus 5. And then I'm going to subtract both items from g of x. So minus 2x plus 3. And then combine like terms, and I get 3x squared minus 3x plus 8. So I'll box this answer, and I'll box my previous answer. All right, now I'm going to find the product. This is probably the most difficult of the four of them. So f times g of x. All right, so I'm going to take 3x squared and multiply it to both items in g of x. So 3x squared times 2x is 6x to the third. 3x squared times negative 3 is negative 9x squared. Now I have to distribute negative x to both items in g of x. So that would make negative 2x squared. I'll write it underneath so it's easier to combine later. And then plus 3x. And now multiply g of x by the plus 5. That would be plus 10x minus 15. Combining like terms. We get 6x cubed minus 11x squared plus 13x minus 15. All right, division is one of the easier ones because you don't actually have to do long division or synthetic division. You could just write it as a fraction. So if I find f over g of x, I just write f on top of g of x. So that would be negative 3x squared minus x plus 5, and then on top of 2x minus 3. And then the only somewhat difficult part, then you have to add when does the denominator equal 0, because that is not allowed. So if you look at the denominator, 2x minus 3, the value 3 over 2 would make that equal 0. So here's our answer for the quotient. So you write f on top of g, but then you have to figure out what makes the denominator 0, and we restrict that. That's called a domain restriction. Okay, moving on to number 2. We're going to find all 4 again. So we'll start with the sum, f plus g of x. There are no like terms to combine here, so we just write the two of them with a plus sign in the middle. And if you look at the directions say to indicate any restrictions in the domain. So this one actually has a restriction in the domain, like the quotient did on the last problem. Anytime you have a variable in the denominator, anytime you have a variable in the denominator, that variable or that denominator is not allowed to equal 0. So then we have to restrict it and say that x does not equal, and the value that would make that denominator 0 is -1. So that's our domain restriction. X does not equal -1. Okay, so for the quotient, we do the same thing. There are no like terms. So we just write x squared minus 1, and then we subtract the g of x fraction. All right, same thing. Domain restriction, denominators are not allowed to equal 0. So x cannot equal -1. All right, for the product, we're going to multiply both items in f of x by 1 over x plus 1. So this is going to become x squared over x plus 1 minus 1 over x plus 1. And we have two denominators, and both of them require that x does not equal -1. Okay, for the quotient, we're going to have to flip and multiply. So we're going to take x squared minus 1 and multiply it by the reciprocal of g of x. So x squared minus 1 times x plus 1. And now I'll just multiply this out. So this is x cubed plus x squared minus x minus 1. And even though our final answer does not have a denominator, any denominator that appears anywhere in the problem is not allowed to equal 0. So we still have the domain restriction. And so you might look at that and think, well, we don't have any fractions anywhere in that problem. I skipped a step at the beginning. I skipped the part where we have x squared minus 1 divided by 1 over x plus 1. So even though I never wrote it, there was a denominator at the beginning of the problem. And even though that gets flipped later, it's still not allowed to equal 0. Okay, on the back, we're doing the composition of two functions. So the way you read this right here is f compose g, and then the other one would be g compose f. That's not an O, it's not a 0, it's an open circle, it's not a multiplication dot. So the way you read that is compose. We're going to compose two functions together. Okay, so let's start with finding f compose g. So I'm going to write it like this, f compose g of x equals, now I'm going to make braces. When you're finding f compose g, start with the coordinates in g. All right, so I look at the first coordinate in g. I see a 1. I see a 1 in the x and a 3 in the y. This 3 in the y magically takes you to that 3. So you're trying to match the y from the g with the x in the f. So that magically takes you here. So then we're at a x of 3, and then that coordinate has a y of 3. So then think about, okay, we started at 1 and we ended up at 3 for that coordinate. All right, I know it's a little confusing. We'll try it again. I'll switch colors. So we start at this point. It takes us here. Then we have to look, okay, is there a 4 in the X for the other list? So this 4 takes us to that 4 because they're the same number. And then that takes us to 1. All right, so where did we begin? We began at a 3. 3 was the X coordinate for G. And we ended up at 1. Okay, so for the next one, start at 2. That takes us here. Then we teleport to that 2, and that takes us to 4. So that coordinate will be started at 2, ended at 4. Okay, for the last coordinate in G, starts at 4, takes you to 1. Now you look for a 1 in the X's for the F. Takes us here, takes us here. So that coordinate, the very first X coordinate it started with was a 4, and then the Y coordinate that it ended with was a 2. All right, so those are the coordinates of F compose G. All right, now we're going to find G compose F. So this is going to be backwards for G compose F of X. Start with the coordinates in F. Start with the coordinates in F. So I'll use my highlighter. So if I start at 1, 2, now I'm looking for a 2 in the G, in the X's for the G points. So that takes me here, which takes me here. All right, where did we start? We started at 1, and we ended up at 2. Started at 1, ended up at 2. Okay, next one. So we'll start with this F coordinate. 3 takes you to the next 3. Now you're looking for a 3 in the X's, which takes us here, and we end here. So started at 3, ended at 4. Okay, for the next G coordinate, or actually when we're doing G compose F, we start with the F coordinates. So 2, and then 4. Now we look for a 4 in the X coordinates of the G. Takes us here, which takes us here. All right, so remember, where did that path start? It started at 2 and ended at 1. So 2, 1. One more coordinate in F. So we start at 4. That takes us to 1. Now we look for a 1. Whenever you switch from F to G or from G to F, you're looking for the number that you were just on. So 4 took us to 1. 1 matches with the other one, and that takes us to 3. So our coordinate there is 4, 3. Okay, for part B, we want to find F compose G of X. So you always start with the second letter, so we start with the G coordinates. And, well, notice we start at 3, that takes us to 7. There are no 7s in any of these X coordinates. All right, so we don't have anything for that coordinate. Let's do the next coordinate. Next coordinate, -2, takes us to 6. There are no 6s in the X coordinates on the F list. So we try the next point. 4, -2, and then I don't see any -2s in these x's for f. 8, 10. I'm trying to find a 10 in the x's for the f, and I don't see any. So this one actually does not exist. Okay, so f composed g of x does not exist. So now let's find g compose f of x. So for g compose f, we start with the coordinates in f. Start with 5, -2. This -2 magically takes us to the other -2, which takes us to 6. So where did that start? Started at a 5, ended at a 6. All right, next coordinate. 9 takes us to 7. I don't see any 7s in the x for the g list, so that one doesn't take us anywhere. -4 takes us to 3. Then we have to teleport to another 3, which we have. So that coordinate started at a -4 and ended at 7. All right, last one. Let's see, 0 takes us to 1, and there is no 1 in the x's for g, so we are done. There were only 2 coordinates. Okay, and lastly, for number 4, we're going to find the composition of 2 functions, but this time they give us equations. So for number 4, A, we want to find f compose g and g compose f. So for f compose g, of x, you take the second letter, so you take g, and you plug it in to the x for the other function. So there's going to be 2 times -5x minus 1 plus 7. So I replace the x in f of x with -5x minus 1, and then I simplify. So this is going to be -10x minus 2 plus 7, which is -10x plus 5. All right, so that's what f composed g of x equals. And then we also have to write the domain and range. So the domain is all real numbers. There is no real number that we are not allowed to plug into x. Usually the domain is not all real numbers if there's a fraction. If there's a fraction, you need to make sure the denominator does not equal 0. I don't see any denominators, so all real numbers for our domain. The range. So if you recall from the previous chapter, if the function is odd, x has a exponent of 1, so this is an odd function. If the function is odd, one side goes up and the other side goes down, and because of that, the range is all real numbers. For this graph in particular, the left side is going to go up forever, and the right side is going to go down forever because it's linear and it has a negative slope. Okay, so now I want to find a g compose f. G compose f of x. So I'm going to do pretty much the opposite. Now I'm going to start with the f function, and this gets plugged in right there. So that's -5 times 2x plus 7 minus 1. So that's -10x minus 35 minus 1, which is -10x minus 36. Okay, that is also linear. Linear functions have a degree of 1 because it is odd. The domain is all real numbers, and the range is all real numbers. Remember that when the degree is even, the range will definitely not be all real numbers. Okay, so let's begin part B by finding f compose g of x. And that's where you take g and plug it in for x in the f equation. So this is going to be x minus 9 squared plus 2 times x minus 9. All right, if we multiply x minus 9 times x minus 9, we get x squared minus 18x plus 81. And then we're going to add 2x minus 18 to that. So this becomes x squared minus 16x plus 63. Okay, so recall that is a quadratic, which means the graph is a parabola. It is a parabola that opens up. When a parabola opens up, it has a minimum. So remember, the domain for a quadratic equation is all real numbers. The range, however, you have to find the vertex. So because that's a minimum, I know the range is going to be y is greater than or equal. And now I have to find the y coordinate of that vertex. So if I do negative b over 2a, that would be 16 over 2. I know that the x coordinate of this vertex is 8. So now if I plug in 8 for x, do that in your head or off to the side. If I plug in 8 for x, I'll just show the work here. I get 64 minus 128 plus 63, which is negative 1. So the vertex is 8, negative 1, which makes my range y is greater than or equal to negative 1. Now let's find g compose f. G compose f of x. We take that by plugging f into g. So that'll be x squared plus 2x minus 9. That's another parabola. We know the domain will be all real numbers. In the range, this parabola also opens up. So we know it has a minimum, which means the range is going to be y is greater than or equal. Let's find the vertex. So if I do negative b over 2a, negative b over 2a would be negative 2 divided by 2. So negative 1, comma, plug in negative 1 for x. That would be 1 minus 2 minus 9. That would be negative 10. So my range would be y is greater than or equal to negative 10. Okay, one more of these. So for f compose g, you take g and plug it into f. So that'll be negative 4x squared minus 1, which makes 16x to the 4th minus 1. The domain for that is all real numbers because there's no denominator. Remember, all we're really worried about is no denominator can equal 0. All right, the range. Well, the range is definitely not all real numbers because it's even. We know when it's even, it's either both ends up or both ends down. This is going to be both ends up because the leading coefficient is positive. So because it's both ends up, I know again we have a minimum. Whenever you have a minimum, y always stays greater than or equal to that value. So I'm going to show you guys a way to find the minimum by just thinking about it logically. So if you think about x to the fourth, so I'll write it up here. What's the smallest this could possibly be? The smallest that could possibly be is 0. If you think about what happens if you plug in a negative. Well, if you plug in a negative, it goes positive. If you plug in a positive and you raise it to the fourth power, it also goes positive. So a negative to the fourth is positive. A positive to the fourth power is positive. The smallest you could make that circled part is 0. So if the smallest this could be is 0, think of it this way. 16 times 0 minus 1. That's the smallest that the whole thing could be. So the smallest this could be is negative 1. And the reasoning being the smallest that x to the fourth could be is 0. So the minimum is negative 1. Okay, G compose F of X. And now we're going to take F and plug it in to the G equation. So this is negative 4, and then x squared minus 1 squared. So I have to multiply that out. Negative 4 times x to the fourth minus x squared twice, so minus 2x squared plus 1. So this becomes negative 4x to the fourth plus 8x squared minus 4. So there's our composed function, and now we just need the domain and range. So again, domain, all real numbers, the range. Okay, the range, we know this is even. We also know that both ends are going to be down. So this is going to have a range that looks like y is less than or equal to some minimum value. Okay, so I'm going to think about this logically again, and I'm not going to look at the simplified answer. I'm going to look at the unsimplified answer. Whenever you square something, the smallest it can be is 0. So the smallest that this could be is 0. Anytime you square something, if you square a positive, it's positive. If you square a negative, it's positive. If you square 0, it's 0. The smallest anything squared can be is 0. So the smallest this can be is 0. And now when I multiply it by a negative, that kind of makes it go backwards. Instead of the smallest it can be is 0, well, the negative flips it upside down. So now the biggest it could be is 0. All right, hope that wasn't too confusing.